Hello, good day to you, friends. Today I'm talking about vmstat. So this is part of a series of video about performance analysis of the Linux operating system. So performance analysis, they are activities that you do when you want to understand what is going on in your system, or when you want to understand maybe why a particular application is crashing, running slowly, the system is slow, the network is congested. So you want to analyze your system to know what's going on. So vmstat is actually one of the tools, in it is one of a lot of tools that are out there. So and that is what I'll be talking about today. So let me start my timer and let's go to the terminal. So vmstat, you can run vmstat ordinarily, and it gives you some output. So this output captures a lot of things that is going on the system. So if I run man on the vmstat, it tells me, so for example, that vmstat reports information about processes, memory, paging, block IO, traps, disk, and CPU activity. So this captures a lot of things about the system. And so each of these parameter, they have their own unique meaning, and we'll be going over the meaning of this. So it is important that you understand the importance of each of these parameter, or from the standpoint of your daily activity. And even maybe you need to go for an interview, like it has happened to me. I went for an interview and I was given this output, like okay, and I was told to explain the meaning of each parameter. So it is important for you, as a maybe a DevOps engineer, as a systems engineer, as a performance engineer, that you understand this output. So let us go through them one by one. So like I said, there are ways, there are like very common ways that you run vmstat. One of them is running vmstat ordinarily. Another way is you can run it with an interval. So for example, what this means is interval of 2 seconds and 4 counts. That means I want 4 outputs, each at interval of 2 seconds. So this is going to give me 4 outputs, interval of 2 seconds, basically, so that I'll be able to get an average, or a more or average overview of what's going on the system. So another way that you can run vmstat is another common flag is dash a. So dash a gives information about um active and inactive. If you look at the difference, the above gave information about buffer and cache, but this gives information about inactive and active. So those are like the three common ways of running vmstat. So let's run vmstat again. So let's go through these parameters and to understand what each of them means. So the first one is R. So if you look at vmstat, you see R, A, R, then you see number 4 under it. This stands for run queue. Run queue, stand for indicate the number of processes that are waiting, for CPU time. They are ready to run, and they want to take on the CPU. So they are waiting for CPU time. So that is the meaning of the arrow that you see there. So uh so you see 3, now you see 0, now you see 1. So but in a high performance environment, or in a server environment, if you see a high number for R, that points to some performance issues on your system. So something that's related to that, how maybe what is called load average. So load average also gives an indication of the utilization of your CPU. if you have very high load average and also very high run queues, that points to some issues on your system. So let's go back. So the next one I'll be talking about is B. So B, also stands for processes that are waiting for resources. But in this case, they are waiting for input, something like input output, disk, or network. So if you have a high number under B, that means maybe you have some performance issues, with your maybe your disk IO, your network IO. So that is what that means. So let's keep going. The next one is swapped. So swap is amount of swap space that is being used. So swap space. So if another way by which you can say swap space, if you run free, so free will tell you the amount of swap space that is being used. So right now I'm not using any swap space, and you see here also it's reports 0. So in a very high performance environment, you your swap use should actually be 0. If you see any usage of swap space in a high performance environment, that points to a problem. So another one is the free. So the free refers to amount of unused memory. So if you go to our vmstat output, you see free. So this is the unused memory. So if you look at this output and compare it to the free output, they are roughly the same. So it refers to the amount of unused memory. So the next thing is I have to run this with vm-a because to see this output, inactive and active. So what inactive means is so inactive means recently unused memory that can be reclaimed. These are like maybe an application that has run and it has closed. So the memory unused by the application can be reclaimed. So that is inactive. So active, is recently used memory. Maybe an application that is running. That. So basically, memory that has been used recently. So buffer. Let's go to buffer. So to see buffer, you see you have to get used to this output. Some of them you see it with vmstat. Some of them you have to run it with vmstat-a. Most prominently inactive and active. So buffer. So that is the buffer cache in RAM. So buffer. The Linux operating system uses buffer because when you do something, if you write something, when you write maybe a couple of bytes, the system doesn't write immediately to maybe the disk. It writes first to buffer. So that's this buffer memory, buffer area. So the next one is cache. So cache is a page cache in RAM. So cache, what does cache means? So cache is the area of memory where recently used memory or recently used data are kept, because they might be reused very soon. So that is the cache. So the next one are under swap. So you can see that these outputs are broken down into segments. First were the processes. The next one was memory. Now we go to swap. So swap, you see two outputs under that. Swap in, swap out. That is what that stands for. So the swap in, that is the amount of data from swap area, from the swap memory to the RAM. So swap out is, data from RAM to the swap area. If you see in my case, I have a zero for both of them. Like I said, in a very high performance environment, this value should actually be zero. If you start seeing very high numbers under swap in, swap out, it points to the fact that maybe you need more memory on that system. So high values of swap in, swap out, means maybe you need more memory, more RAM on that system. The next one, is IO. IO. So this IO basically, block in, block out. That is what this means. So blocking refers to number of block per second from the block devices, or a number of blocks. The block out sent means number of blocks sent to the block devices. So if you are on a something like a database, if this server or is running like a database, you might see some very high numbers under block in, block out, or maybe a system that's maybe is a file server, a database. You might see a large number under the block in, block out. So the next segment is uh, the system. So the system, under the system, you have something like IN. What does IN mean? IN stands for interrupts. So interrupts, that is the number of interrupts per second. So interrupts per second. Uh, so you if you have a high number of interrupts, that might also point to maybe some hardware interrupts, maybe some other forms of interrupts. If you want to know other forms of, like, what is this? For example, under here I have the interrupts is 312. So you can look into the cipher called proc interrupts. So it's going to give you details of the kind of interrupts that you are having. Very high number of interrupts might also be, at times it might be good in a high performance environment. Yeah, maybe. But at times it might not be what you want. So but it tells you the interrupts per second. So the next one is context switches. So context switches is the number of times the CPU need to move some processes out of the CPU and moving another process. So basically switching context. So this high number of this also might point to might degrade the performance of your system. If you have a lot, maybe for an particular application, you have a lot of context switches, that might be something you need to uh, take care of, because context switches are expensive, things to do. So the next one we have is US. So that US actually stand for this percentage. This is actually like percentage of CPU, used for in the user space. As you know, the Linux system is divided into the user space and the kernel space. So the next one is SY, which is system. So it stands for percentage, also percentage of CPU, or percentage of CPU for system space, that is basically kernel space. So ID is the next one here. ID stands for idle time. So like the percentage of time that the CPU is idle. So You see here I have 86. That means my system is actually very idle, or my system, this particular system, is not doing a lot of work. So in a high performance environment, you will see this might be very low because the CPU is doing a lot of work. So the last two is WA, which is the time that was lost from waiting for input output. So that is time used to wait for input output, maybe block IO, disk IO, or network IO. So this last one, most you see this on physical machine most times, is stolen time by virtual machine. So if you are running a virtual machine on your system, so you'll see this time is refers to the time that was spent, servicing the virtual machine is refers to as stolen time. So yeah, that is all. And I hope if you want to like understand, you can watch this video again, so that you basically have a better understanding. So like I said, each of these parameter, they point to how healthy or unhealthy your system is. So for example, some of the most important one may be the run queue. If you have very high number of run queue, yeah, that may be a problem for you. If you have high number of uh the block IO, so waiting for input output, basically waiting for something, yeah, that may also be a problem. If you start seeing a lot of swapping, swap outs, yeah, so it points to the overall health of your system. So, and I hope maybe you learn one or two things. If you have a comment or question, you can put it in the comment section so that we can learn about it. So thank you for watching. See you in some other videos. Bye.